Almost everything within your reach right now crossed an ocean inside a steel box that looks exactly like tens of millions of other steel boxes. That sameness is not boring. It is the single most important design decision in the modern economy. To see why, you have to picture how shipping worked before it. For centuries, cargo moved as what the industry called break bulk. Goods arrived at the docks as a chaotic jumble. Barrels, crates, sacks, loose machinery, all different shapes and sizes. Gangs of longshoremen loaded each item by hand, wedging them into the hold of a ship like a giant three-dimensional puzzle. It was slow, it was dangerous, and it was staggeringly expensive. A ship could spend more time sitting at the dock being loaded and unloaded than it spent actually sailing. And every time a human hand touched the cargo, there was another chance for it to be dropped, damaged, or quietly stolen. Loading a ship could take a week or more, and the cost of all that labor made shipping goods across an ocean a serious expense in the final price of almost everything. The fix came not from a shipping company, but from a trucker. In the 1950s, an American named Malcolm McLean, who ran a trucking business, was sitting at a port watching his cargo get unloaded from his truck and slowly hand-loaded onto a ship. And he had a simple, almost obvious thought. What if you never unpacked the truck at all? What if the whole container could just lift off the truck chassis and drop straight onto the ship, sealed the entire time? In 1956, he tried it. A converted tanker called the Ideal X carried 58 containers from New Jersey to Houston. It does not sound revolutionary, but the economics were shattering. Loading cargo this way cost a tiny fraction of the old hand-loading method, and the idea that would reshape global trade was born on that one voyage. But a good idea is not enough on its own. McLean's real insight and the reason the system works is standardization. A container is only magic if every container is the same, and if every ship, every crane, every truck, and every train is built to handle that exact size. If each company used its own dimensions, you would be back to chaos. So in 1968, international standards bodies locked in the dimensions we still use today. The most important unit is the 20-foot equivalent unit, or TEU, a container 20 feet long, 8 feet wide, and 8 feet tall. The 40-foot container is simply two of those. Once the whole planet agreed on those measurements, something remarkable happened. A box packed in a factory in Vietnam could be sealed, lifted onto a truck, driven to a port, stacked on a ship, sailed across the world, lifted onto a train, and delivered to a warehouse in Ohio, without a single person ever opening it or repacking what was inside. The container became a universal language that ships, ports, trucks, and trains all speak. This is the idea the industry calls intermodal. Multiple modes of transport, ship, rail, and road, all handling the same standardized unit seamlessly. And it is worth pausing on how strange and powerful that is. The value is not really in the steel box itself, which is just corrugated metal. The value is in the agreement. Because everyone committed to the same shape, the entire journey became a smooth handoff instead of a series of expensive unpackings. The container turned shipping from a labor problem into a logistics problem, from something you solve with thousands of workers into something you solve with cranes, software, and scheduling. That shift is what made it possible to manufacture something on the other side of the world and still sell it cheaply at home. There is a small piece of engineering that makes all of this physically possible, and almost nobody notices it. The corner casting. At each of a container's 8 corners sits a steel fitting with an oval hole, and everyone is in exactly the same place on every box in the world. A device called a twist lock slides into that hole and turns 90 degrees, and suddenly 2 containers are locked together, or a container is locked to the deck of a ship, or to a truck chassis, or gripped by a crane. That one humble fitting is why a box can be stacked 7 or 8 high on a rolling ship and not topple, and why a crane can grab any container on Earth the same way. The corner casting is the quiet handshake that lets the whole system connect. Standardization did not just mean the outside dimensions matched. It meant the exact points where the world grabs and holds the box matched to down to the millimeter. It also changed what the world could sell to itself. Because a container is a sealed, weatherproof, lockable space, it protects fragile and valuable goods from the weather and from theft in a way loose cargo never could. And because the cost of moving one box fell so dramatically, it suddenly made economic sense to ship things that would never have been worth shipping before. Cheap furniture, seasonal clothing, bottled drinks, car parts, electronics, even refrigerated food in special cooled containers called reefers, all of it could now travel across the planet for a trivial cost per item. When you spread the price of an entire ocean voyage across the thousands of individual products packed into one container, the shipping cost of any single item shrinks to pennies. That is the real reason a product made 10,000 miles away can still be cheaper than one made down the road. Once the box was standard, the ships could grow, and grow they did. The earliest container ships carried a few hundred boxes. Today, the largest vessels on the water, a class known as ultra-large container vessels, can carry more than 24,000 TEU. Let that number sink in. A single ship carrying over 24,000 containers. If you tried to move that same cargo by truck, you would need a convoy of trucks stretching for well over 100 miles. These ships are among the largest moving objects humans have ever built, and yet they are run by a crew of only around 20 or 30 people. Because once the cargo is in standard boxes, the ship barely needs anyone to tend it during the voyage. Interestingly, the ships have roughly stopped getting bigger, not because we cannot build them, but because the ports and canals that serve them can only handle so much. The ship is now limited by the world it has to fit through, and the economics are relentless. A bigger ship spreads its fuel and crew cost across more boxes, so the cost to move a single container keeps falling as the vessels grow. That is the engine behind decades of shrinking shipping costs. Not one breakthrough, but the steady march toward larger and larger ships, each one carrying more for less, until the ports themselves became the ceiling. When one of these giants arrives at a modern port, you see the second half of the system in action, and it is a breathtaking piece of choreography. Towering ship-to-shore cranes, some over 400 feet tall, roll along the quay. Each one reaches out over the ship, locks onto a container with a device called a spreader, lifts it, and swings it to shore in well under a couple of minutes, then repeats, all day and all night. Several cranes work a single ship at once. Below them, a small army of vehicles, straddle carriers and reach stackers, whisk each box away and stack it in precise locations in the yard. And none of it is guesswork. A terminal operating system tracks every single container, where it is, which ship or truck it goes on next, and exactly where to place it so it can be found again. Even so, fully unloading and reloading one of the biggest ships can take a full day or more of non-stop work. That yard full of stacked containers looks like random chaos, but it is the opposite. Every box has a planned position because the order matters enormously. A container that has to come off first at the next port cannot be buried at the bottom of a stack. So before a ship even arrives, planners build a detailed stowage plan deciding exactly where each container sits, balancing the weight so the ship stays stable, keeping refrigerated boxes near power, keeping hazardous cargo apart, and making sure everything can be unloaded in the right order at each stop. A single ship might visit several ports on a loop, so the puzzle has to work at every one of them. It is a constantly running optimization problem, and getting it wrong means either an unstable ship or hours wasted digging for a buried box. There is one more piece of the puzzle that most people never think about, and it reveals how the whole system really behaves. Empty containers. World trade is not balanced. Some places, like large manufacturing regions, ship out far more than they bring in. Others, heavy importers, receive far more than they send back. That means containers pile up empty where they are not needed and run short where they are. So a huge, costly part of the system is simply moving empty boxes back to where the goods are. Ships and trucks carrying nothing but air in a steel shell, just to reposition the container for its next real load. It is a quiet, expensive tax on the whole network, and it exists purely because trade flows one way more than the other. Sitting on top of all this hardware is an invisible layer that most people never see: the schedule. The big shipping lines run their vessels on fixed loops, almost like ocean bus routes, calling at the same ports in the same order, week after week. A single loop might string together a dozen ports across 2 continents, with one ship arriving at each stop roughly every 7 days. To keep that rhythm, lines pool their ships together into giant partnerships called alliances, so that a handful of companies effectively coordinate most of the boxes moving on the world's busiest routes. This is why your package can be given a firm delivery date before the ship has even left Asia. The route is not improvised. It is a repeating timetable, and the container is simply booked onto it like a passenger onto a flight. When that timetable holds, the whole global supply chain can plan around it. When it slips, the delays ripple outward through every business waiting downstream. And it does slip in ways that show just how tightly wound the system has become. Because everything depends on ships arriving on schedule and ports clearing them quickly, a problem in one place spreads everywhere. A surge of imports can overwhelm a port faster than it can unload, and ships end up anchored offshore waiting days just for a berth. Once that happens, the effects cascade. The waiting ship is not on its next route, the containers on it are not being returned, the trucks booked to collect them sit idle, and the empty boxes needed back in Asia never arrive. A single stuck ship blocking a canal or one major port slowing down can tangle supply chains on the other side of the world within days. The very efficiency that makes container shipping so cheap, running everything lean, on time, with little slack, is also what makes it fragile when any one link jams. Put it all together, and you have a system of astonishing scale that almost nobody notices. Roughly 80% of everything traded in the world by volume moves by sea, most of it in these boxes. The system is so reliable and so cheap that we have built our entire way of life on the assumption that a product made anywhere can appear on a shelf near us for a reasonable price. We only notice the machine when it breaks. When a single ship wedges sideways in a canal or a port clogs up, and suddenly shelves go empty and prices jump. The rest of the time, the greatest logistics achievement in human history runs silently in the background, measured in identical steel boxes. So the next time you see a container on a truck on the highway stacked at a port or riding low on a ship at the horizon, remember what it really is. It is not just a box. It is a physical piece of an agreement the whole world quietly signed, that we would all build to the same dimensions so that goods could flow across the planet without ever being unpacked. The genius was never the steel, it was the sameness. The shipping container is the most important object of the modern economy that you were never taught to notice. An empty steel box, made powerful by the simple fact that every other box is exactly like it.